The first question is coming from one Mr. Mohammed from Oman. How to select the capacity of a vacuum pump for a central plant? That's a very good question, because plants are large in size. Now, vacuum pump should have the capacity to evacuate the entire system, right? Now, we have a chart where we can show you, or we can tell you what exactly this is. Now, so we have this chart out here, data for selecting a vacuum pump. The data for selecting a vacuum pump is given below. Now, one column is plant capacity, and the second column is pump capacity in CFM. Plant capacity in TR and pump capacity CFM. Up to 10 TR, the pump should be minimum 1.5 cm, and it goes on increasing 10 to 15 TR 2 CFM, 15 to 30 TR 4 CFM, 30 to 45 cm as it goes along, right? And then above 130 TR, then the pump capacity should be 24 CFM. Let me minimize this. Let me share the screen. Before we come to the capacity of the vacuum pump, let me show you this animation. This is the black dot is the air in the system. It travels through entire system, right? And this is the components of air. This is how the air travels throughout the system. And this is about the moisture system. This is the, now take a look. This is a setup for the vacuum. The micron gauge, the readings are coming down, right? This is how the vacuum takes place. $700 and up to, we can take it down up to 500 microns. And we have 530, 520, 510, and stop. This is the setup of the system. The vacuum pump, this is a manifold. This is, you have a ball valve, the micron gauge, and this is how it is connected to the system. So this is what I was talking about. Okay. Enter option. So this is the PR capacity, and this is the CFM capacity of the pump. That was the answer to the first question. Where is an automatic air relief valve fitted? This is what from Mr. Sheikh from Nigeria. Now, this air relief valve is used for purging the air in the system, water lines. Now, water contains a lot of air. If air remains system, then it creates a serious problem. So air must come out of the system. It comes out of the system through an air purging valve, which is fitted on the pump delivery side. I will just share the screen with you if it's possible. This slide shows you, let me run this slideshow. of current slide. Now take a look at this. This is how red dots are the air, and as the pump rotates, the air also leaves the pump. This is air purging valve. Now this is how it works. Air purging valve in a float ball, right? It moves up and down, and the air escapes from here. Take a look at the next slide. This is how it is. Air comes out of the water, right? And this air goes out. When the air goes out, the water comes in place here and it closes this valve. Okay. This is this stop share. Now, the next question was, it's on the electrical point. This person from UAE asks, what is the difference between TPN and TPMCB? Okay. TPN means triple pole with neutral, and TP means triple pole only. Along with this, he has asked, what is the difference between MCB and MCCB? This person is from UAE. Now, before the electricity enters the system, there must be control, a protection switch, basic switch, so that we can control the flow of current. Now, in central plants, basically, we have three-phase supply. That is red, blue, yellow, RYB. So the switch will have three contacts for cutting off all the three phases. N means the neutral is also disconnected. Now let me show you on a slide if possible. So we are come to this. Let me see if I can do it for you. (23). Yeah, just a minute. 23, slide number. Let me share the screen. Share the screen. So first, let us see carefully. Slideshow. The current slide. Now, this is. Now take a look at this. Now the main power comes here and it goes into the panel. Here, main switch, condenser pump, cooling tower, compressor. Okay. Now these are the switches that are trying to show you. Now we come to this. The switches. Now take a look at this. Now types of MCBs. First, single pole. First is single pole, right? the single pole. Is suppose red phase, we have only single phase supply. Then this MCB will switch off this phase. Double pole means two phases of phase are neutral. See, the pressure increases, right? Now we open this valve. The pressure will reduce and it will result in cooling. Okay. Now, if you repeat this process over again, this is air conditioning. This is very, very basic way to understand this, right? What's the next question? He says, what is neutral in a power supply? Okay, what is in a power supply? We'll come to this. In this slide, we have, this is the topic is electric essentials in a course material. What is phase? This is a supply end in an AC supply. So it is denoted by P. Means this is the supply source. What is neutral? This is the return end in an AC supply. Now this is a supply. Supply goes in this direction, goes to the electrical equipment, which we call the load, and the return path is called neutral. Okay. I'll just elaborate one more thing on this. Now take a look at the central plant. How to charge gas in a central AC plant. Someone from Indonesia. Okay. Module. I'll open this module for you. Now can you see this slide? This is for the reference charging. But before we do the reference charging, let me show you the setup for the vacuum process. Now, vacuum is called evacuation. Now, this is a system, this is a plant. It will have a service valve, right? And this is a manifold. The 3 points in the manifold. Center point goes to your reference cylinder. This cylinder must have a dipstick so that liquid only flows into the system. The right one goes to the vacuum pump and the left one goes to your service valve of the compressor. Here we have a straight ball valve and here is the vacuum pump. Sorry, micron gauge. This is the basic setup. Vacuum takes place. Now, let me run the slide for you. Slide show. Current slide. Now take a look at this. This will remain closed throughout the process. Okay. Step 1. Open V1, right? It opens up. Step 2. Open this V2 compound gauge valve. This opens up. Step 3. Discharge gauge valve. Oh, this opens up, right? Step 4. Open the service valve, SV, within Allen key, that opens up. Now start the vacuum pump. This will record the vacuum reading, and when it comes up to 500 microns, then stop the vacuum pump. Moment you stop the vacuum pump, then the vacuum begin to rise. But the maximum limit allowed to rise up to 1500 microns. Only then, there's no leak. Now, let's take a look at this now. 10,000 now, 5,000, 1,000, 500. Now close this valve. Close this valve, right? Stop the vacuum pump. The vacuum will rise. If it does not exceed 500 microns, then it is okay. Then you close this valve and the vacuum process complete. Now the charging process starts. Take a look at this. The charging process V1 and V3 will be, sorry, back to this. Slide show, current slide. I would look at it again. V1, V3 will be closed throughout the process, right? Step 1. Note the weight of the cylinder, 5,000 grams. Okay. That is. Open V4, cylinder bulb. The refrigerant begins to enter from here, via this, and into the system. And this level will begin to fall. This is entering. The liquid level of the refrigerant will begin to fall. Take a look at it. When this gauge will rise, when it is 1,100 psig, then start the machine, right? And regulate the amount of gas through this valve. Note the reading out here. When the amount of refrigerant is entered, what is the requirement? Then what you do? You close this valve. Third, close V4 and V2. This one. Then check the circuit of the gas charging. Okay. This is the complete setup and how the vacuum takes place and how the refrigerant is charged the system. Okay. This is available in detail from our practical course, Central HVAC Professional, Central HVAC Plants, Model 13. Let's see what's the next question now. Right. There's one more question. One person is asking is, what are the reasons for high head pressure in a central AC plant? So let me open that respective module. This module is related to troubleshooting, and it covers all the various issues. Someone is asking why head pressure. So let me go through all for the benefit. First is high head pressure. That's one reason. Why that high head pressure? One, in an air-cooled condenser, you can have a dirty condenser, low airflow from the condenser fan, the air not flowing through this condenser. Non-condensing gases system means your refrigerant is impure, it is containing some air and some other impurities. Next is excessive internal loads. Suppose the internal loads have increased, occupancy has increased, or some equipment load has increased. And next is installation of chiller. Now, suppose you have installed this air-cooled chiller in the open direct sunlight, it will affect it, right? So environment also plays a very important part in the head pressure of the plant. That question was for high head pressure. As long as when you've opened the module, you can go through all this. These for high head pressure of water cooled system, less water flow, dirty strainer, scaling in condenser tubes, cooling tower issues, impurities of non-condensing gases in the refrigerant. Then you have low head pressure. Then you have high suction pressure. Reasons are given. Low suction pressure, and the various other issues. Reasons are given here. Then you have warm suction line. They are given cold suction line. So many other shortage of refrigerant, and so many reasons are there. Right? Another question just asked on this topic was, why do the what you call pipeline vibrate? water pipeline vibration. Here we are. So this, you must have noticed that sometimes these pipelines begin to vibrate violently. What's the reason? The reason is there's air in the system. This air causes knocking inside the pipeline, resulting in vibration. So this is like, not only that, it will damage the impeller also. Let me run the slide for you. Slideshow from current slide. Take a look at this. See, the pipe is vibrating. So as explained earlier, the question was, this is released by the air purging valves. What is the next question we have here? There was a question of what is an SLD? SLD in an electrical drawing. SL means single line diagram. From this diagram, the entire setup, electrical setup is shown. Okay. Now, exactly that, I'll just explain this to you also, what an SLD looks like. Now, take a look at this SLD. Now, take a look. Now, this is what the main cable coming. Single line diagram means it is showing you on only one phase. Every phase will have a fuse. Now we have the voltage selector switch and a voltmeter. So this phase will have a voltmeter. This phase will have an indicating light. And this phase will have a voltage selector switch and a fuse. Same with here, ampere meter. Now for an ampere meter, we'll have this current transformer, ampere selector switch, multifunction meter. Then we come to this. This is MCCB. Then this is the bus bar. Let me see the next slide. Here it is. Take a look. Take a look at this right now. This is a cable. I mentioned this. This is a single cable, right? Of the three phases. This is one of them. This is 240 square mm XLPE. All this we mentioned at drawing, type, size and type. What is XLPE? Cross-linked polyethylene cable. That means it is the details of the type of insulation. Then we have the control wiring of this voltmeter. Okay. Then we have this current transformer with ampere meter. Now this ampere meter is supposed to read up to 400 amperes. Now you can't have a meter reading up to 400 amperes. It will be huge and large. So we read it in small values, right? And accordingly, we have a current transformer with a ratio of 300:5. Means 300 ampere will show you 5 ampere on this scale. Okay. So what we do, we have a current transformer, and then this ampere meter will carry only up to maximum of 5 amperes rather than carrying up to 300 amperes or 400 amperes. Then this shows you a 300 ampere MCCB, right? Then this you have a bus bar. Then this is the bus bar. This is a connector bus bar. This is the main bus bar. And then this comes down here and all the cables. So this will go to compressor, 75 kilowatt, size of cable, type of cable. AR stands for armored cable. This is a 200 ampere TPN MCB, 40 ampere TPN MCB, 63 ampere TPN MCB, 25 ampere TPN MCB. So this is a complete SLD which mentions the kilowatt load, the cable capacity, the type of insulation, and then the bus bars. Everything is shown out here, and then wiring is done according to this. That was that question asking me about What is an SLD? So you explain what is an SLD. What's the next question? Take the next question. Out. Then you close this. What's the next question? Next question is, oh yes. This is one other question from controls. Someone has asked me one question on controls. Question is, how does the control of a plant done? How it control? How you control the safety of the plant, right? Now, let me show you this slide. It will show you, right? We have basically many safety devices. First, we have a starter. Then we have a thermostat. Then we have HPLP cutout, and then oil pressure sweater. Now, all the controls, the contacts of all the controls will be in series to the supply. A single phase supply will go through all the contacts of all the controls, right? And then this is connected to the no volt coil of the contactor. So when all the contacts are closed, the no volt coil of the contactor will get the supply. It will become a magnet and the starter contacts will come on. If any of these trip, then that will switch off. Now explain this to you. I will share this slide with you. Take a look at this. Okay. Close this slideshow. Now take a look at this. As the supply, all this closed with a magnet. What is working? Now let's say HP. So HPLP switch tripped because of high head pressure. When this trips, this circuit is disconnected from the neutral. So this circuit cannot complete. When this cannot complete, this coil will no longer remain a magnet, because to complete the circuit, we need the phase and the neutral. So this will become de-energized, and this contacts will open and the motor will stop. This is how the controls work. There was another question regarding how do sensors work. This was a very interesting question asked by somebody. How do sensors work? This is a question from Pune, from some Mr. Mahesh from Pune. Now take a look. I've made this slide on sensor control circuit. Just take a look at this, how it works, and I'll explain it to you. That was the audio part of the slide, right? Now you see, the temperature increases, this starts conducting, the supply goes up this, then this positive comes down, it makes a complete circuit. This coil gets energized, relay contact closed, and the compressor starts. Right? Got it? NTC is a semiconductor whose resistance changes with the temperature. So when the temperature increases, in this case, the NTC resistance decreases, and this is the NTC. When the temperature increases, the resistance decreases, then this positive potential comes here, right? Then this relay coil circuit is completed through the transistor right here. And when this relay circuit is completed, it gets energized, contacts here close, and the compressor starts. So this is the DC control circuit, and this is the power circuit only for the purpose of running the compressor. So let me show you another one. Now this is showing an heating cooling thermostat. Take a look at this first. Red color indicates a flow of current. Okay. Now cooling circuit is like this. Just a minute. Just pointer option, but not start. There's a pointer. Okay. This is the red is the flow of current. This starts conducting. This gets energized. This contacts will close and the compressor starts. Okay, that is now the cooling circuit. Okay. Now we come to the heating circuit. Take a look at the heating circuit. Okay. Now we rotate it to the heating side, heating option, heating mode. Goes like this, goes like this. When this circuit will complete, this coil become magnet. This contacts will close and the heater will come on. This is how heating cooling thermostat operates. So we have two modes. One is cooling mode and heating mode, and the selection is done through a rotary selector switch. That was answering that question, how sensor control circuits work, how a sensor works. There's one question out here that why do we put wooden blocks when you're installing water pipe on hangers? Okay. Now, to explain that point, I'll show you that point. Let me open that relevant slide for you. Let me now slide show current slide. Take a look. Complete steps are shown to you. Drill two holes. Just a minute. Slide show. Take a look at this. Take a look at this now. We'll drill two holes. Drill two holes in the concrete ceiling. Here we have one hole. Then this will be the second hole. Okay. Explain to you how that complete is done. Then we insert dash fasteners. These are special fasteners which expand the moment you put the bolt inside. Then you put the bolt inside, second bolt inside. Look. And take a angle, suspend it like this, put the nut out here, then lift this, put here, close this nut, and put another nut out. Right? Let me explain what the question was. Question of why do you put wooden blocks? First of all, wood is an insulating material. So if the pipe is chill water pipe, then heat will not travel from this thing, metal parts to the pipe, and you'll have no sweating. Blocks, wood is also a vibration sort of eliminator. It will hold the pipes and it is in U shape, so the pipe rests perfectly inside without any problem. This is what the complete installation.